So if we have the 20 coffee drinkers and 12 non-coffee drinkers, and I want to find the probability of randomly choosing a coffee drinker. I won't do this, but I'm just saying, I want to find the probability. What is the probability of us randomly choosing a coffee drinker? So I want to write the notation, and then I'm just going to write my answer, which consists of the number of ways that E can occur divided by the number of possible outcomes. So here for my notation, anytime we're looking at probability, it's a capital P, and then in the parentheses, we're going to put what we're interested in, that our event. So I want to know choosing a coffee drinker. So you can abbreviate all you want and anything you do for me. I definitely abbreviate all of the time. I'm just going to write coffee so it's clear here for the example. And so here it's the number of coffee drinkers in the class, right? That's the number of ways that E can occur. So that's my 20. And I'm going to divide it by the total number of students in the class, or the number of students that took the poll at the beginning of the class. So out of 32 students. Okay. So when we look at probabilities, I don't care how you guys write these. I don't care if you simplify them. You definitely don't need to simplify anything for me, but you can. But you can write it as a decimal, you can write it as a percentage. So you could say, okay, well, this is 0.625. Or you could say, okay, well, this is 62.5%. So I want you to know there's multiple ways to write probabilities. And typically going forward in other chapters, we're going to use the decimal form. And once in a while, we'll use a percentage form. I don't really use the fraction form. Although I know, like in algebra, we're so used and kind of forced to reduce. You do not need to reduce for me. Okay, we're not an algebra class. I actually will tell you, like on an exam, I prefer to leave your answer in this form, because then if everyone has the same form, then it's just easy for me to recognize your answer instead of trying to translate it into 3 or 4 different forms. But I want you to know your work is your own. I want you to write this however you're comfortable with. If you want to reduce, if you want to write it as a decimal, or write it as a percentage. Okay, so here we could just say, okay, I have a 62.5% chance of randomly selecting a coffee drinker out of our class right now. Like if I ask someone to help me with a question, right? So when we're referring to, I want to say like interpreting an answer or writing an answer in just layman's terms, like so in terms that anyone can understand, someone that's not in stats class, really the percentage is the way to go. Because in stats class, we're going to learn that, okay, if I say, well, we have a 0.625 probability of randomly choosing a coffee drinker, that makes fine sense, and it will make complete sense to us all through stats, because we're going to use it all the time. But someone that's in stats is going to say, I don't know what that means, 0.625, right? They're not going to get it. But if you say, well, I had a 62% chance, then someone gets it, right? So we always think about that when we're writing answers, writing interpretations out. How would someone interpret this, or be able to read this and get this answer based on not being in a stats class? Okay, so we kind of keep that in mind too. Although you'll see, I'll give you a lot of what we call a statistical answer for everything. Okay. All right, so when we're looking at calculating probabilities, I told you I'm going to give you 2 different ways. One way is a formula way, which some people really feel concrete and they like that because they're a math person. And that's fine. It's always how I did it. And then the other way is called a 2-way table. I actually really like the 2-way tables. I encourage you guys to use the 2-way tables in our class. I will always supply them. So in an exam or anything, I will give you the 2-way table. So let's take a look at what these 2-way tables are. I think they're really easy to read, and they make sense. So when we have 2-way tables, I want you to know that we're studying 2 variables when we have these. Okay, so like today are two variables. I asked you two questions, but I just had them all in one answer. You're a coffee drinker or not, and then what year student you are, right? So I had two variables going on there. And let me see. Okay, so when we're looking at these, I'm gonna draw it out actually. We'll use it. So got my coffee drinkers. You guys can see your results. Non-coffee drinkers. We're going to use these in some examples. I'm going to show you how to use this table. The year students we are. I had like included myself. I said we. Fifth year students. Here I'm going to put a total. I'm going to include a total down here. And I'm just going to fill in this table. Okay. So let's see, let's choose a different color so it stands out, maybe. So we had 7 coffee drinkers that are first year, 6 non-coffee. So it's pretty split. 9 coffee drinkers in their second year and 5 non-coffee. So it's leaning a little bit more towards coffee. And then my third year, like I mentioned, when you guys are taking the poll, I have no non-coffee drinkers. All the third year students are coffee drinkers. And then it's split for my fourth year students, and I have 1 5th year, and that student is a coffee drinker. So I'm just going to total these up. So I already totaled them up. We have 20 and 12, 32, and then this would add up to 32 as well. There. Now this number down here, this is called my table total. Okay, that's called my table total. As you see, that's the number of students in our class, the number of students that took the little poll there. Okay, so first, let's take a look at some examples here. So the first example, I'm going to write it out in words and we're going to write it in notation so we get that practice in. So we're going to look at the probability of choosing a second year student. So I need to grab something first. I totally forgot to grab it. Where is this? Sorry guys, I forgot I do it this way. I actually grab maybe. Let's see. Sorry guys. It's somewhere is in here. Well, maybe it's not. Oh, here it is. Okay. Sorry, I forgot. So I can keep using the same table over and over again. I actually grabbed this. Sorry for the reflecting lights. I actually grabbed this little piece of like plastic from Collins Toy Box. So I can shade in the table. So when we're using a two-way table, like I said before, we have 2 variables. So it's the year student and the coffee drinker, non-coffee drinker. And I'm going to calculate probabilities using this by shading the table. I love this. It makes it so simple. You don't have to think about probability rules. You don't have to think about any of this stuff, okay? So I apologize. I see they're reflecting. I can't turn all the lights off because then we wouldn't have anything that's not helpful. Okay, so when we're looking at the probability of choosing a second year student, what we're going to do is we're going to write the notation and then we'll write it out. So the probability of choosing the second year student here, I'm going to get this here, is capital P. And then I'm just going to kind of abbreviate for whatever I need. So I'm just going to put second. I could put second year, whatever. You could be specific and say second year student. But this is just taking this statement and writing it out in notation form. So now what I'm going to do is I'm going to shade. So when we're shading the table, I'm going to get a couple colors out from here. So when we're shading this table, what we're doing is we're going to shade what I want to call like our interest or what we have, like what we're studying. And then it's always going to be by the table total today. Okay, that will change next class. But for right now, we can just know it's going to be out of the table total. So what I'm going to do, I want to know the probability of choosing a second year student. So I'm going to take these second year students, and I'm going to shade that in. And what it is you're ignoring kind of the totals and you're just going to shade in your table. So what happens when you are calculating these probabilities, your numerator is going to be every number in the shaded part added. So it's going to say, I know it's 14, but I'm showing you. It's going to be 9 plus 5 in my numerator, and then it's going to be my table total in my denominator. So it's going to be the 14 out of the 32 here, okay? Does that make sense? So I just shaded in what I was interested in, which is second year students, both. It doesn't say one or the other, coffee or non-coffee, so both, which I know I have my table total. So it's the 14, but I want just, what I'm trying to show you is that you're going to shade, and then whatever you're shading is what you're adding each once. Okay, so that makes that's a big deal when I say each once. Okay, so let's take a look at the next one. So let's see here. What do I want to do? Let's take a look at the probability. Let's kind of combine a couple things. So let's look at the probability of choosing a second year student or a coffee drinker. Okay, so when I'm doing this, I'm going to write my notation out. So again, I'm going to erase this shading, pull the whole thing down. So again, here, I'm going to write my notation. So I'm looking at the probability, and I'm just going to fill it in. Second year student, and I'm just going to actually write the word or coffee drinker. And I can write this another way. So I'm going to write an equal sign so we know I can write it a different way. The probability of a second year student, and I'm going to use what we call a union symbol, and it just looks like a capital U, kind of. Okay, so that's my union symbol. That represents or. That's a notation for or. So here I have that, and I'm going to use my table shading. So I want to highlight or shade in the table everything that's an interest to me. So I'm going to shade in my second year, which we've already had. I kind of could have just left that. So my second year students, and I'm also now going to shade in coffee drinkers. But what I want you to recognize is you can see it here. I have an overlap, right? I have the intersection of where the two, the column and the row intersect, right? Those 9 students, but it doesn't matter when I'm using the table, because I'm going to keep in mind my numerator is going to be all of these numbers in the shaded regions added once. You see what I have here? So I have the 7 plus the 9 plus the 2 plus the 1 plus the 1, which I know that's 20, right? My table. And then plus the 5. I'm not going to add the 9 twice, right? I'm adding up all the numbers shaded once. Okay. And again, this is out of my table total. So I have my 20 plus my 5. So I have 25 over this 32. And that's how I'm going to find probabilities using my two-way table. I love it. It's so simple. It just takes out all that wondering of the rules and memorization of rules from using formulas. I will show you the formulas though as well. So let's look at one more. And the last one we're going to look at is actually called an AND problem. So let's take a look at the probability. Let's see. We'll change it up from the second year students. Choosing a fourth year student, and so the and is key here. A coffee drinker. So what we're studying here, we want to know what is the probability that I'm going to choose someone at random from our class, okay? And that they're going to be a fourth year student that drinks coffee. That's what I'm looking at when it's an and. They're both. Sorry, this is like not. There. Okay, so that's what we're going to look at. We're looking at the overlap is what we want to call this. Okay. So we want to look at people that fit in both categories. So if you're in both categories, so we're looking at fourth year students that drink coffee, it's just this one square, right? It's like the intersection of the two, just the one. And again, I'm going to write my notation, capital P, and I'm going to say fourth year, and I'm going to write out and then I'm going to put coffee, or I can write it like I did before with symbols. So I'm going to say fourth year, and the symbol for an and is actually just upside down union. So it kind of looks like a large lowercase n. So it's my union symbol flipped over. This is called the intersection. My coffee drinkers here. So here I only have one number or cell in my table shaded. So it's just that one, again, over the table total. So it's 1 out of 32. So I don't have much chance of choosing someone that's fourth year coffee drinker at random. If I was choosing one of you guys at random, I don't have a very good chance of that happening. Okay. So when we're looking at these, I want you to know this is one way of solving these problems by using a two-way table. Now, yes, you have to have all this data and this information available to you in order to use this method, which I'm saying I will always provide a two-way table. I will always provide a two-way table. Okay. The other way is using rules in formulas. So let's take a look at these rules and formulas. These, to me, they're just as easy because I'm a math person, but it doesn't mean it is for everyone else. Okay. So I'm going to just call this the probability of A or B. And let's just call this, sorry for your notes. I'm only going to give you, I think, 3 formulas. What I'm doing right now, we're going to pick up with these next class. So I want the probability, the formulas for probability of A or B. Now we already did that, right? Because we looked at second year or coffee drinker, and I already forgot what it was. It was 25 out of the 32, right? So we can still do that using formulas. So I'm going to use my notation. So the probability of event A, or so I'm going to use my union symbol, event B, is just equal to the probability of event A occurring plus the probability of event B. This is what we call a special case. I have to know something before I can use this situation, okay? And the special case just means that these are mutually exclusive. So I'm going to write this all right here. So event A and event B are mutually exclusive. And what that means is that there is no overlap. So if two events are mutually exclusive, it means there's no overlap. So you can see with the table where there's overlap, right? So mutually exclusive means that there's absolutely no overlap, meaning if I wanted to look at coffee drinker and non-coffee drinker, there's no overlap, right? You can't be both of those categories at once. Or there's no overlap between the year students you are, right? Because you can't be both a first year and a second year all at once. So that's what we call a special case. So it's the or, okay? Probability of A or B is my addition rule. Let's write that up here. Now I'm going to give you the addition rule when we don't have mutually exclusive, or maybe we don't know if they're mutually exclusive. Okay, so this is one. Give myself some room. So the probability of A or B, my notation looks the same because I'm still calculating the same thing, probability of A or probability of B. And this is going to be equal to, it's going to look the same, probability of event A plus the probability of event B, but I'm going to subtract out what we call that overlap, the probability of A and B. So remember when I showed you in the table, A and B was the overlap, right? It was where someone fit in both categories. So this is when they're not mutually exclusive. This is my general rule. So let me just say this somewheres here. This is my general rule. I can always use this general rule, but I want you to know that they are not mutually exclusive. So what you need to do is you're subtracting out the overlap. Okay, and that's what we're doing in here. We're going to subtract out that overlap. So that's what this portion is. So this is what I mean when I say that I think the tables are simpler. And the reason for that is you don't have to worry about, oh, are they mutually exclusive or are they not, right? Do I have to subtract that overlap or don't I have to, right? So it takes that out when you look at the table, because when you look at the table, you say, oh, I'm just going to shade whatever I'm interested in studying and divide it by my table total. Okay. So that's what I mean when I say sometimes the rules can be a little bit more difficult because we have so much we have to worry about. Okay, so I'm going to give you another formula. And this is, I'm going to start this. We're going to pick up with this next class because we need some more information. And that's what our whole next class is based on. So let's take a look at the probability of A and B. So this is my and. So let me just kind of recognize, okay, we're looking at or here, we're looking at and here. And is the intersection, and is the overlap. I'm going to give you the special case today for this one. So I'm going to write it out in the notation. So we have the probability of A. Now, and is my intersection. So it's like my union symbol, but upside down. So it looks like a capital N upside down, but really kind of large. I'm sorry, a lowercase n, just really large, sorry. My intersection symbol. And this is going to be my multiplication rule. So it's the probability of A occurring times the probability of B occurring. Now, like I said, this is the special case. We'll write this here. And when we have a special case, we have to make sure it fits that mold. So like up here with the addition, A and B are mutually exclusive. I have to make sure that's true in order to use the special case. For the special case here, I need to make sure that A and B are independent. And two events are independent if one does not affect the other. So A and B would be independent if the occurrence of A happening does not affect or change the probability of B when it occurs. Okay. So what I want you to think about is the probability of A happening, okay, and the probability of B happening just separately on their own, right? And I have a probability of that occurring. when A occurs, does that affect B or vice versa? If B occurs, does that affect A? If it does affect it, then they're not independent. But if it doesn't change the probabilities, they remain the same, then that means these are independent. Okay? So just keep in mind, independence means that B does not affect A when it occurs and vice versa. A does not affect B when it occurs. Okay? So those are my rules. Maybe I'll show you a quick example here. I'm just going to squeeze it in here. We have a couple minutes. Well, look at this. So if we have an example, so maybe I want to look at the probability of snow. I have to say snow because we're in that season for the next 3 days. Oops, got caught there. So I want to know, what is the probability of the next 3 days? So maybe the probability is 50% each day. Okay, it's 50-50. It's going to snow or not. So I'm just going to kind of make a note of that. The probability of snow equals 50%. So if I want it for the next 3 days, what I'm looking at is the probability. I'm going to abbreviate with just an S because I'm running out of room. The probability of snow times the probability of snow times the probability of snow. Because what I'm really looking at, I'm just writing this backwards in my notation, but I'm looking at the probability of snow and snow and snow, right? So if it snows today, it's independent if it snows tomorrow or the next day, right? So if it snows today, that doesn't change the fact that I still have a 50% probability of it snowing tomorrow, and then the same for the third day, right? So these are independent events, one day from another to another. So here I have 0.5 times 0.5 times 0.5 because we said the probability of it snowing is 50%. I have to have that information. Okay, so it's 0.5 cubed, I can write it, or 0.125. I just want to get the idea through you that it doesn't have to be 2 events. It can be 3 events, it can be 5 events, it can be 10 events, right? So I can have multiple events here, and this rule could still be applied. So it's like probability of A, B, and C, right? It's just that they're all the same thing, that they're snowing. Okay, and that's like using the formulas. I like the formulas. Like I said, I used to use the formulas all of the time. It's not that they're bad. It's just sometimes it's hard to distinguish if we have a special case or not. But if you keep in mind, you could always use our general rules. We're going to look at the general rule for probability of an and, okay, or multiplication rule. I do want to write that down, multiplication. We're going to look at the general rule next class. So here's our multiplication rule, okay, our A and B. Let's see here.